Hello again, everybody. What I'm going to do in this video is just break down, again with a right angle triangle, and look at some of the trigonomic functions that we can use to solve either an angle or one of the sides of our triangle. So a common question that I get is, Jason, how do I identify when I need to use Pythagorean theorem? How do I know when I need to use trig? And they're actually both interchangeable. But I like to say, just as a starting point, if you are looking for the side of a triangle and you already have two sides, Pythagorean theorem is a one-step process. It's just Pythagorean theorem. If you wanted to use trig, it actually would work 100%, but you're going to have to do the trig function in order to find that value. So if you've already been, you'll have to find an angle, and then you'll have to find that side. So if you already have two values, two lengths of your right angle triangle, you want to solve for the third, just use Pythagorean theorem. It's a one-step process. Can you use trig? Absolutely. And if that's what you're comfortable with, keep on that path because that'll be important. Okay. So our three trig functions, this is when I only have one side of my triangle and I have one angle. Other than, I always know this is 90 degrees, I need one more angle. So when I only have one side of my triangle and I have an angle, I can use a trigonomic function in order to solve for the other components. So the three trigonomic functions that we're going to use are sine theta, which is equal to the opposite over the hypotenuse. That's one of the trig functions that we can use. The other trig function that we can use would be cos theta, which is equal to the adjacent over the hypotenuse. And the last one that we could use tan function, which is tan theta is equal to my opposite over my adjacent. So one thing we have to be very careful with is that how do we pick which one I need? Well, you have to look at what you have in place. So this follows the same rule as any right angle triangle. This side that is the longest side of my triangle, that is directly across from the 90 degree, the right angle, this will always be my hypotenuse. It has to be, this has to be the longest side of my triangle. That always has that name. So if we have the hypotenuse, and say we were given angle theta right here. We were given that angle and it was, I don't know, let's say it was 52 degrees, just for argument's sake. So I have my hypotenuse, okay? If we give this angle, let's say that this was 20 millimeters long. That's how long my hypotenuse was, and I wanted to know one of the other sides. When you're picking a trigonomic function, look at what you've been given and then pick the function you have. I have an angle. Okay, well, all of these have angles. That's fantastic. I have a hypotenuse, so automatically my tan function is out because this isn't a relationship with the hypotenuse. This is the relationship of the opposite and the adjacent. Hypotenuse doesn't exist in this formula, so this is not one of the functions that I can use. So now I look at my sine theta and my cos theta. Both of these have hypotenuse in it. They both have an angle. Fantastic. I just have to look at what I'm solving for. If I want to solve for the adjacent, okay, this is adjacent because it is right beside the angle that has been given. So that side of my triangle has a name when I am looking with respect to this angle. So if I'm trying to solve my adjacent, I would use cos theta as my trig function because that's the relationship of the adjacent and the hypotenuse. So then I would have to just transpose this, and my formula would be hypotenuse times the cos of 52 would give me the magnitude of my adjacent value. So if I was looking for adjacent, I would use cosine in this case. I couldn't use sine because this isn't that relationship. If I was looking for the opposite, in this case, when I've been given 52 degrees, well, that angle, the side of this triangle is now opposite from this angle. So if I'm looking for the opposite, I would now use the sine function, because that is the relationship of the opposite and the hypotenuse at a specific angle. So I hope this has helped just to identify which trig functions that we need to use in any case. And in the next couple of videos, I'm going to go through and we'll actually solve the sides of these triangles so we can see the numbers and how those relationships work. So I hope this has helped. We'll see you in the next one.